So let's go through these two then. So there's a couple of examples. I've written the laws of logs up here on the left-hand side. Hopefully, the more practice we do, and perhaps if you've looked at these at the past, they'll just become second nature to you because they won't be given in the exam, okay? So it's like formulas or anything like that, so you need to know them, all right? But again, the best way of learning them is just doing loads of practice with them, and then they'll just become like second nature. Okay. So let's have a look at question 1. So here I haven't given you the base at all. The reason being is I don't care what that base is, okay? So log of 4 plus log of x equals log of 20. Okay, fantastic. So can you tell me then how to go about answering this? So what have you done?
I put 4 plus x equals 20.
Not quite. Have a look. So you've got log of 4 plus log of x. You're happy with logarithm 1, or laws of logs 1. It says if you add two logarithms with the same base together, you should effectively just multiply the bits inside them. So it shouldn't be add.
Yeah, 4.
You said 4. Okay, sorry. I might have misheard then. So log of 4x, are you happy? Log of 20, perfect. And then, yeah, so you look at that and you go, well, okay, I have log of something equals log of something, right? So log of something equals log of something. The only way that that can work is if 4x is equal to 20. So what did you get x to be equal to? Perfect, well done. Now, you should always check one extra thing here, okay? And the one extra thing that you need to check is whether x equals 5 is actually valid. Now, clearly in this case, the way that the question has been set up, I'm looking for a solution, okay? There's only one solution that you get out, so it's highly likely that solution is valid, okay? But I'll show you how to check it all the same. Do you remember what the exponential graph looks like? So if I look at something like y equals 2 to the power of x as an example. Do you remember what this graph looks like? Have you done this with me now? So this graph, and again, if you're not sure what this graph looks like, we've done it in the asynchronous hour, in the pre-recorded lecture this week, so you can go back and have a look at this. Effectively what's happening here is you're doubling every single time you increase by x. So as you move across by 1, you double. Then you move across by 1, you double that value again. Then you move across by 1, you double that value again. So it's kind of like ever increasing, okay? So the way this graph looks like is like this. Okay, so it's an ever increasing graph. Really important thing to note though is that it never ever reaches 0. Think about it. The reason being is because if you move in that direction, so if you move to the right, you're effectively timesing by 2. Okay? Which means if you're moving in the other direction, if you're moving to the left, what are you doing instead? Not negative 2. What's the opposite of times? Divide by 2. Yeah, so you're doubling in this direction, halving in this direction. And of course it will change, what you're timesing by, dividing by, will change according to this value here. But if you think about it, if you move in that direction, you're always going to take a value and you're always going to halve it. Now, if you keep halving values, will you ever reach 0? No, you'll get close to it. It'll get smaller and smaller and smaller, but you're never physically going to reach 0. So in that case, we say that this line here, the x-axis, special name, we call it an asymptote. It basically means that this graph will get closer and closer and closer to it, but never physically reach it. Okay. So let's think, okay, what are my set of input values? What are my set of values I can put in for x? So what set of values can I put in for x? So what values can I put into this function? Are there any restriction? Can I put any value I like in, or can I only get some values that I put in? Would you? Sorry? Okay, so I can definitely put values in more than 0. Are values less than 0 valid?
No.
You sure? Can I put an x value in over here and get a value out up here? For example, if I put in 2 to the power of -1, can I do that? Yeah. Can I put in 2 to the power of -5? Yeah, so I can put in values negative as well. Can put in values positive. Can I put in 0? 2 to the power 0? Okay, so I can, yeah? So in other words, I can put in any value for x. So x can take any possible value. What about y though? Are there any restriction on the values of y that I can get out?
Should be all in positive.
All positive, exactly. So not 0, because we've just said this graph will never ever reach the value y equals 0, and it will never ever go negative. So it's strictly speaking, y has got to be positive. Okay, so that's the graph y equals 2 to the power of x. Now, this is really important. What does the graph y equals log to the base 2 of x look like? So what does the logarithm graph look like? Let's do it in red. So let's look at the graph y equals log to the base 2 of x. Okay, just going to draw in my axes. I'm going to have to squish it in a little bit, but I think it'll be okay. Okay, now we've said right at the very start that logarithms and exponentials are really just inverses of each other. So one undoes the other, okay? So because they're inverses, the idea is that the x's and the y's will swap places. So every single point along this graph, whatever the x coordinate is and whatever the y coordinate is, they'll swap places, okay? Now, I'm not going to kind of go through why. If you are interested, again, look at the asynchronous hour, okay? But effectively, I need to make sure the x and the y swap places. That's just basically a reflection of the line y equals x. Like the x-axis, y-axis swaps places. That's a reflection of the line y equals x, which means that the logarithm graph will look like this. Okay, I've just taken this graph here and just swapped it over, swapped the x and the y-axis over. Okay? Now again, this line here is an asymptote because the x-axis was an asymptote on the exponential graph, which means that the y-axis will be an asymptote on the logarithm graph. Again, I'm just swapping the x and y values over. Okay, so that's an asymptote as well. Okay, okay, fine. So let's just think about the x and the y values on this graph here. Okay, so is there any restriction? Look at this graph here. Is there any restriction on the values of x? You sure? Look at it again.
No negative.
No negative and not 0 either, because we said it's an asymptote. So in other words, x has got to be, strictly speaking, positive. Okay? Is there any restriction on the values of y? No, you can put in any y value, you can get any y value out. So I can take any value down here. Now this is really important, okay? So basically what I'm saying, and I will write it over here, basically what I'm saying is that if I have a logarithm, like y equals log to some base of x, okay, it always has to be the case, because we've just seen down here, whatever my input value is, whatever I put into my logarithm, that has always got to be positive, okay? So in other words, the thing which I put into my logarithm has always got to be positive. It can't be 0, it can't be negative, okay? Can't be 0, it can't be negative. So whatever I put into my logarithm, it has to be positive. Great, let's get rid of all this. And let's just reconsider all that. So that was a kind of a long intermission to kind of see this very simple fact, which is if I have the logarithm of some value, whatever goes inside my brackets, whatever goes inside my logarithm, okay, that has always got to be positive. So have a look up here. Well, okay, 4 is positive, 20 is positive, I've got log of x, okay? So I've got log of x. So that's the only thing which I don't know in this particular equation up here. So that means that whatever I put inside my logarithm, in this case x, that's got to be positive. Okay? Now what value did I get out for x? I got x equals 5, right? Now just check, is x equals 5, is 5 positive? Yeah. So just always do that check. Yes, we're all good. Does that make sense? Yeah, so always, always, always check what you're putting in your logarithm. You need to make sure that input is positive. Okay, let's have a look at this one, question 2. What did you get? How did you solve this?
Log
Yeah?
x to the power 3 over 2.
Okay, so in other words, you raise the power up here, so you've got x to the power 3, and you saw there's a subtraction going on, which means you need to divide. Fantastic. Okay?
Log 20 over
Good. So in other words, again, subtracting these two logarithms and you're dividing. Perfect. Well done. Okay, now what?
X to the power 3 over 2 equals 4.
Good. So in other words, you're saying log of something equals log of something. Those two somethings have to be the same. So that's the same. X to the power 3 over 2. That becomes 4. Good. Now what?
2 multiplied by 4.
So you get x cubed equals 8.
Then x equals square root of 8.
Not square root,
Oh no.
cubed root. Yep.
2.
Good. X equals 2. Now, is x equals 2 valid?
Yeah.
Yeah, we always need to check. So we've got the only thing which we don't know. These are all positive. So 2 is positive, 20 is positive, 5 is positive. We just need to check log of x. So that's the only thing we don't know at the moment. So we have log of x. Well, that implies that x has got to be greater than 0. Okay, the thing inside the logarithm's got to be greater than 0. So let's just check the value which we got. Well, we got x equals 2. Is 2 positive? Yes, it is. So always, always, always do that check. I know it might seem trivial, but always do it, particularly when we look at later examples or examples in just a second. We need to make sure that we've got valid answers there.
We have to do this. Like if it's positive, you know, we need to do it.
Okay, that's what I'm saying. So if you can just see straight away, oh, well, that's positive and I had log of x anyway, that's fine, okay? But I would always encourage you to at least think of doing this, particularly for simple ones, you can think of doing it. But when we look at examples in just a second, they're going to become slightly more complicated and therefore we're going to have to really make sure that we definitely do this, okay? So get in the practice now is basically what I'm saying. Okay, good. Can you have a go at that example on the screen for me, please?